This is example 2 in section 4.5. We're going to work on finding the zeros of a polynomial function, and then actually by using those zeros and looking at the end behavior of our graph, we're going to also be able to sketch a graph of this function. So we look at our function right here. First step is always find a GCF. So when we look at each of these, we find that we can take out -2 from all of these. So when we do that, we get -2 times x to the 4th minus 8x squared plus 16. Now, when we look at this, we can actually see that this is actually x squared to the second power minus 8 times x squared plus 16. So when we factor this, we're going to get -2 times x squared minus 4 times x squared minus 4. Again, when we look at this up here, I want everyone to recognize that this is the same thing as x squared to the, sorry, this is a parentheses right here, x squared to the second power. That's the way we're looking at x fourth minus 8 times x squared plus 16. So this is just x squared minus 4, x squared minus 4. So this is just x squared minus 4 squared. Now, you'll notice that each of these is the difference of squares. So when we go ahead and factor this out, we just get x squared plus 2, x plus 2, x minus 2, and then x plus 2, x minus 2. So this factored out to 4 different binomials, and you'll see that when we actually combine these like terms, we get x plus 2 squared times x minus 2 squared. Again, if we look at this right here, if this is causing you some problems, I would go back to the section 4.4 videos and watch some of the factoring. Here again, we've got, this is just the same thing as x to the second power squared minus 8x squared plus 16. So this is actually a perfect square binomial. It's x squared minus 4, x squared minus 4. So anyways, back to this problem right here. So we're going to see that we're going to have 2 double roots right here. Our solutions are going to be x plus 2 and x minus 2. Because our solutions are going to be x equals -2 and x equals +2, remember, because these are raised to the second power, the graph is going to come up and touch the x-axis but never cross it. Okay, that is something that we learned in the example number 1 video. When our solutions, when we have a multiple solution and it's raised to the second power, if it's an even power, then we know our graph is going to come up and touch that point but never quite go through it. It's just going to touch it and then come back down. So we've got 2 points right here where our graph is going to touch the x-axis but never go through it. Now, we want to see, using some other information, we want to look and see what our graph is going to look like. Now, let's look at some things right here that we know about it. Now, again, this is going back to this 4.1 information right here. So we look at this and we see that this expression is to the 4th degree, which is an even power. Now, if you remember, and again, if you don't, go back and review section 4.1. If you remember, that means that our function is going to have our end behavior behave more like a parabola than a straight line. That means our end behavior means that our function, our graph, is going to have both ends go off in the same direction. So either both ends open upwards or both ends open downwards. And because our leading coefficient is negative, we know that our ends, our parabola-like function or graph, is going to open downwards. Now we also know some other information. We know that if we plug 0 in for x, which is our y-intercept, we know that it's going to be negative 32. So this is a very rough sketch right here. We know that our graph is going to cross the y-intercept at negative 32. Now, we also know that our graph is going to touch but not go through at both negative 2 and positive 2. Okay, now this is obviously a very rough sketch, and we're going to see a better one later. Because we know our graph is going to be opening downward, and we know that it's going to both be touching at both negative 2 and positive 2, we know that our graph is going to look something like this. Again, the reason we know this is that we know that our graph touches the x-axis at both negative 2 and positive 2. It doesn't touch it at any other point. We know that our end behavior has to open downwards and approach in negative infinity in both cases. And we also know that our y-intercept has to equal negative 32 because if we plug 0 into our function, it equals negative 32. Now, this is all behavior that we just got by looking at the original problem here. Now, what I'm going to do is I'm actually going to pull up the Desmos graph so we can check this out. So let's go ahead, go over to Desmos here, and look what we have. We have exactly that. We have a y-intercept of negative 32. Our graph touches the x-axis at both negative 2 and positive 2, and it goes off in the negative infinity in both directions. So here we go, right here. Again, we have kind of this M shape right here, and all of this information we got just by analyzing the problem right here. So we found where our graph touches the x-axis, and we know that it touches this because when we have our double solutions, they are both raised to an even power. So we know that our graph touches the x-intercept but doesn't cross. So we learned this information in 4.1. We learned how to analyze the end behavior, which told us to look at the leading coefficient and the degree of our polynomial. Then we also found out the y-intercept by just plugging in 0 for x. So remember, all of these are tools that you've learned previously in this class. You just are combining them all together to just sketch a rough graph of the function.